Right. So for this one, I believe I went over this one in that lesson 6 video. So what we're going to do for this one is first we're going to look at this graph and pick a coordinate pair from it. So if I look at my line, I want to pick a spot on my graph where this line passes through my intersection points. So if I look at my point right here, let me pick a different. Right here, this line will pass through my grid lines right in the intersections. That's what we want. So if I follow this point all the way down, it tells me that my x coordinate is 3. And if I follow this point all the way to my y-axis, it tells me that the point is 9. Okay, so I have 3, 9. And if you look at your x, is x talking about the amount of gravel, or is it talking about the amount of sand? Which is your x-axis talking about? Sand. Wait, let's double check. Remember, x is on the bottom, so it's going from left to right on the bottom. Gravel, right? No, you're fine. So this is talking about the amount of gravel. So where my x is, where this 3 is, that I'm going to let represent G. Okay. And for the amount of sand, right, that is talking about number 9 because it's on the same axes, right? This amount of sand is on my y. So for 9, I'm going to let that be represented by S. Okay, so 3 pounds is my amount of gravel and 9 pounds is my amount of sand. So once we have that point chosen, the next thing that we need to do is look at all of our answer choices and see which one, if I were to plug in 3 for G and 9 for S, will it give me the same number on both sides? Okay, so let's try this first one here, where I have S is equal to 3 times G. So wherever G is, I'm going to replace it with 3 because 3 is G. And wherever this S is, I'm going to replace it with 9 because 9 is my amount of sand. So I would have 9 equals 3 times 3. And if I simplify this, 9 stays over here. 3 times 3 gives me 9. So 9 is equal to 9. Since those are the same numbers, this one is going to work. So this is an equation that represents this graph. So do you have questions on what I'm doing or where I got my 3 and 9 for, how I know which one is gravel, which one is sand? Or do you feel like you're okay? Uh-oh. Is it better now? Hopefully. Okay. So my question was, are you okay with what I did here, substituting 3 and 9 and for S and G, and then simplifying it, so just multiplying that 3 times 3 and getting the same number at the end? And since I get the same number at the end for both of these, then that means that this first equation is true. It is correct. Are we okay with that? Okay. So now let's check the next one. So our next equation is, oops, G is equal to 3 times S. So what number do I want to replace G with here? Based off of this coordinate pair, what number do I want to replace with G? 3, perfect. And I have 3 times, what number am I replacing with S? 9, perfect. So then 3 is just 3. 3 times 9 is going to give me 27. So perfect, the 27. So is 3 equal to 27? Are these the same numbers? Is 3 and 27 the same? If I have $3, is that the same as having $27? No, right? It's sometimes it's tricky when you're trying to think of it all at one time. But 3 is not equal to 27 because they're not the same number, which means that this equation, the second one, since we did not get the same number on both sides, this one is not true. Okay, so the second one does not work. Now, this third one down here, I automatically know it's not going to work because of this 9. This 9 right here tells me that that one's automatically out because it needs to have a 3. So now let's check that last one where I have S over 3 equals G. So again, I'm going to put 9 in for S. So I have 9 over 3 equals 3. And 9 divided by 3 gives me what number? Three, perfect. And is 3 equal to 3? Yes. So that means that the two answers we want to pick here is this bottom one, that S divided by 3, and the one up here that says S is equal to 3 times G. So make sure that when you're selecting these that you're double checking to make sure it's S equals 3G. Make sure that your variables are on the right side. Then the other one is going to be S over 3 equals G. And let me know when you're okay to move on to the next one. All right. The next one here. So we have this graph that shows the cost in dollars of gasoline. So it shows me how much I pay per gallon of gas. And we want to select all the statements that are true. Okay. Well, if I look here, do you remember how to find your unit rate from this graph? What you look for? Y over X, perfect. So Y over X is our unit rate. And do I want the Y or do I want my X to be 1? Which one do I want to have the 1? The X, perfect. So I want to look where X is 1. So on this graph, if X is, remember, left to right, so if I look at 1 here, if I look at this point, what would be my Y? So when X is 1, what would be my Y here? 3, perfect, right? Because if I'm here at 1 and I go up and I touch my line and then I move all the way to my y-axis, I end at 3. Beautiful. So I pay $3 of gas. Sorry, pay $3 for every 1 gallon of gas. So this first sentence says that the cost of gas increases by $1 for each gallon purchased. Do you think that's true or is that false? I'm paying $3 for every 1 gallon. That means that when I buy 2 gallons, I'd pay $4 if this is true. It's false, right? Because if I'm paying $3 for each gallon, when I buy 2 gallons, I should pay 6, which is what this graph says. So this one's false, so I'm not going to select that one. The next one says if 9 gallons of gas were purchased, the total cost would be $27. So if I look at 9, right, because that's how many gallons of gas I'm buying, and I go all the way up, if I were to extend this arrow, it would pass right through here at this dot right here. And if I go all the way to my y-axis, I end here at $27. So if I buy 9 gallons of gas, would I pay $27? Yes, exactly. So this one is true. And then what about the one underneath it that says the cost of 1 gallon of gas is $3? That one true or false? Yes, that one is also true. So far these two are true. The next one says 0.00 on the graph means no gallons of gas were purchased. So down here, it's saying if I buy 0 gallons of gas, I pay $0. That true? Well, think about it. Do I have to pay for gas if I'm not buying any? Right? So this one down here is also true, which means these three are true. Because if I am buying no gallons of gas, I'm not going to give them any money because I'm not buying anything, right? Same thing like if I'm not paying any money, I'm not going to get any gas. So this one's also true. And the last one says point A on the graph represents the cost of 21 gallons of gas. So remember, gallons of gas is on my x-axis. So if I take this point A and I bring it all the way down, it tells me I'm at 7 gallons of gas, not 21. So that very last one there is false. So the three that we want to select for this one are these three that I have highlighted here in blue. So let me know once you've finished. Go on to the next one. Alrighty. The next one. So Joseph works at a restaurant where he makes a constant hourly rate. Joseph wants to calculate that hourly rate, so he graphed the amount he was paid and the hours he worked for the last 2 days. So one day it looks like he worked 6 hours, and when he worked 6 hours, how much did he get paid? When he worked 6 hours based off of this graph. So when Joseph worked 6 hours, how much did he get paid? $44.70. Perfect. Right? Because if I follow this dot all the way to my y-axis, I end at this 44.70. He says that when he calculated his unit rate, he thinks he gets $7.55 per hour. But he made a mistake. So if after 6 hours he earns $44.70, that means, remember, money always goes on top when we're writing our ratios. So I have $44.70 for 6 hours. If I want to have a 1 in the bottom for 1 hour here, I would do 6 divided by what number to get me that 1? Close. My end goal is 1, right? If I do 6 divided by 1, that just gets me 6. 6. There we go. Any number divided by itself gives you 1. So 6 divided by 6 gives us 1. So we're going to do the same thing to the top. And I'm going to pull open Desmos so I can type this in. So I have 44.70 divided by 6. And it tells me I should get $7.45. So how much money does Joseph actually make per hour? So how much money does Joseph actually make per hour? When we solve this, what does he actually make per hour? The 745, perfect. And make sure that when you're typing this in that you don't put the dollar sign. So just put in the 7.45. That's number 4. Okay, so here we have a graph and it's talking about the population, which is the amount of people that live in this, and then it talks about the number of car accidents based off of the number of people that are in the city. So it looks like this first dot here, I'm going to do this so I can draw off. So this first dot here, if I go straight down, my population is 1,000. Remember, this is my x, so I'm going to write 1,000 first. And when I follow this dot to my y-axis, there's no number here, right? But when I look at my grid, I have 0, blank, 6, blank, 12, and so on. So do you know what each of those tick marks on that graph is going by? What number am I counting by on my y-axis? 6 is. That's if I skip every other one, right? I have this one in the middle that's missing. So what is, there's 2 grid lines to get to 6. So what is 6 divided by 2? So what is 6 divided by 2? 3, which means that this first line right here that doesn't have a number next to it should have a 3. So after 6, 3 more than 6 would be what number? 9, perfect. So right here would be a 9, which is where this point right here intersects, right? When I go all the way to my y-axis, it ends at 9. So I have this point, 1,000, comma 9, and then 15 to 18. Perfect, yes. And then this number right here would be a 15. Perfect. Okay. So this first dot on my graph represents 1,000, comma 9. So 1,000 represents what? That represents, is that how many people there are, or is that the number of accidents? The population, perfect. So this 1,000 represents P, the population, and 9 represents the number of accidents, right? A. So remember how you said earlier we write the y over x? Here, that's going to be A over P. So 9 will go up top, and 1,000 will go on the bottom. And we need to make this to where, so what we need to do here is we need to get this to where there's a 1 in the denominator equation. So to go from 1,000 to 1, I'm going to divide by what number? 1,000, perfect. So I'm going to do the same exact thing up top. So 9 divided by 1,000. And I'm going to pull open Desmos. And when I do 9 divided by 1,000, I get this decimal 0.009. Okay, so remember when you go to write your equation, you have y equals kx, where k is your unit rate. So this, what I have circled here in red, is going to be k. And we have a and p. So I'm going to have a is equal to 0.009 p. So this is going to be our equation for part A. So A equals 0.009 p. Alrighty. So the next question wants to know what does the statement correctly, or which statement correctly interprets the equation. This one I'm going to erase what we did here, because all we really need is this last part as well as this coordinate pair. So when you read through these, remember how we said this population was represented? Population is represented by 1,000, right? And out of those 1,000 people, 9 of them have been in a car accident. So with these first 1, 2, 3, 4 options, which one do you think is correct based off of this coordinate pair that we have here? Remember we said that there were 9 car accidents for every 1,000 people. So do we think it's the first one, second, third, or fourth? Do you think best fits? The first one, exactly. There are 9 car accidents per day for every 1,000 people in the town, using both of those numbers correctly. Perfect. All right. So let me know once you're good with that one, and we'll go on to the next one. All right. 5. To reserve public pool party, and she needs to hire a certain number of lifeguards, L, based on the number of guests, G, that attend the party. Okay, so we have this graph here. These are the number of lifeguards she needs to have on the bottom, and on my y-axis up and down, my vertical, this is how many people she can attend, or how many people she could invite. It says that she concludes that she can use the equation G equals 25L to determine the number of lifeguards she must hire. Since she is inviting 200 guests, she has lots of friends, she computes 200 to equal 25L and solves for L and finds the number of lifeguards. Yeah, so the first thing that we want to check, because part A is asking us to see if she made any mistakes. The first thing we want to do is check out her equation here. Okay, remember that for our unit rate, we want to look where 1 is in the x-axis. So if I look here where 1 is, and I bring this straight up to where it touches my line, and then take this part and move it over to my y-axis. Now there's no number here, but it's a number that's bigger than 15 and less than 30, right? Because it's in between these 2 points here. Did you think that this number here could possibly be 25? over 1. So close. So in order to check this for sure, what we need to do is pick a point exactly through my where I follow my grid, which looks like it's going to be right up here. Right, this point up here looks like my line's going exactly through my grid mark. So if I bring this all the way down, my x is 3 and my y is 75. So if I have 3 comma 75 and I need to put y over x, I have 75 over 3. Get a 1 in the bottom, divide by 3, divide by 3. 25 divided by, 75 divided by 25 is going to give me 25. Exactly, perfect. So 25 is actually correct. And it's hard to tell when you're looking at a graph like this, kind of guesstimating it, especially when you have a pretty big gap, which is why sometimes it's just more useful to go straight to where you can find a point and then simplify it to where you get 1 in the denominator. So her equator is correct. This G equals 25L because her unit rate is correct. And if she's inviting 200 guests, well, the guests are represented by G, right? And so she's substituting in this 200 for G. Right, so this 200 for G, which she did correctly. So it looks like all we need to do is solve this equation to figure out how many lifeguards she needs. So for part A, Perla did not make any mistakes. She set up the equation correctly. That's part A. She didn't make any mistakes. She set up the equation correctly. And so now we have to isolate L. So to get rid of this 25, the opposite of multiplying by 25 would be what? Dividing by 25. Perfect. So when we divide both sides by 25, this is going to cancel. 200 divided by 25 will give us what number? Two hundred divided by 25 gives us which final answer? 8. Perfect. So part B would be Perla needs to hire 8 lifeguards. So 8 lifeguards, and she did not make any mistakes. And let me know once you have both those chosen, and we'll go on to the next one. Alrighty, number 6. So Rafaela wants to determine the amount of recyclables they can expect to recover from an incoming load of 80 pounds of trash. So this graph here shows us the pounds of trash and how many pounds of recyclables they have. And it says that she finds the unit rate as represented by the point 1, 0.08 and sets up an equation R equals 0.08 T. Okay. So let's check this equation first because this is another one that asks us if she correctly computed. So when we're checking this equation for R equals 0.08 T, we're checking to see if this unit rate here is correct. So if I look at this point on the graph here, my X is 10, right? If I follow this point straight down, it's 10. And what is my Y? When I take this point and follow it all the way to my Y axis, what's my Y value? 0.8, right? It's okay. It's fine. It is kind of tiny for you, so it's okay. All right. So from here, we're going to put our Y over X, right? So I have 0.8 over 10. We're going to divide by 10 on top and bottom. And if you type in 0.8 divided by 10 in a calculator, you will get 0.08. So this step right here works out because her unit rate that is up here in her equation is good. So that works out. So she's good there. The next one says that they're expecting 80 pounds of trash, T. So she takes that 0.08 and multiplies it by 80. That's the next thing we're going to check. So 0.08 and multiplies it by 80. I get 6.4. She also got 6.4. So it looks like she did everything correctly. So that is B. So let's see. For A, there is 0.08 pounds of recyclables recovered from every 1 pound of trash. That's our unit rate. And then for B, we want to choose the one that says Rafaela's work is correct. She correctly determined the unit rate, equation, and solution. So these two answers are kind of far apart. There are 0.08 pounds of recyclables. And then she is correct. So our next one. So this graph is talking about the length of yards of fabric for cost per dollars. The first blank wants us to figure out how much it costs per yard. So on this one, if I look here, this one we can kind of guesstimate, and it's actually not that bad to guesstimate. Remember, when we're using a graph, we're looking for where x is 1. So if I follow this up and then bring it over, it looks like that point is in between 2 and 4, right? But remember, I have this blank right here. So if I'm going 0, blank, 2, what number would I put on this first blank? 0, blank, 2, blank, 4. I'm counting by ones, right? So this blank right here would have a 3, and this blank down here would have a 1. Perfect. So it looks like this line is in between 3 and 2. Do you agree? Through 3 and 1. Yes, and perfect. Okay. So since our 1, right, a point where 1 is in between 2 and 3, we're looking at a range that is in between $2 and $3. So if I look at all these blank ones, which price is in between $2 and $3 for cost per yard? So which one of those blanks is in between $2 and $3? Um, 2 and 3. Yes, but so which one of these price ones? This like is $3.50 in between $2 and $3. Is $2.67 in between $2 and $3. Which one of the actual price values from the answer choices would fall in between $2 and $3? The one that's bigger than 2 but not more than 3. Are you saying the third one? So this one down here that says okay, there you go, 267. You pay $2.67 per yard of fabric. And blank 2 is asking for an equation. Okay. T is our total. D is cost per yard. So I'm going to put dollar per yard. And L is our length of the fabric. Now, I don't know if you remember, but last semester when we were talking about money does go on top, yes. Last semester when we were talking about setting up equations with word problems, I told you that your total should always go by itself, okay? Which means that here, since we have a total, our t is going to go on one side of the equation and there's not going to be anything else next to it. Which means when I look at these answer choices here, I'm looking at either this one down here with the t by itself or this one in the middle with the t by itself. Now this is kind of where you have to think about the problem a little bit because it looks like I'm either multiplying or I'm dividing here. If I were to go to the store and I buy some apples, right? Each apple is 50 cents. I buy, let me do it this way. If I go to the store and buy apples, each apple is $1, right? If I buy 8 apples, how much money am I spending? Each apple is $1, and I'm buying 8 apples. How much, what would be my total? $8, right? So I'm taking 1 and I'm multiplying it by 8 because that's how many I'm buying. I'm taking the price of 1 apple and I'm going to multiply it by 8. So here, if I am paying $2.67 per yard of fabric and I buy 5 yards of fabric, would I want to multiply that or divide it to get how much total money I'm spending? Think about it. When you are dividing numbers, your final answer will get smaller. If you are multiplying, your final answer will get bigger. Right? So multiplying, yes. And you can kind of try it. So like if I'm buying 5 yards of fabric and I do 5 divided by 267, I get this number here that's smaller than it would be for 1 yard of fabric. Okay, so sometimes you just kind of have to play with the numbers a little bit. But yeah, so for blank 2, I'd want to have T equals BL for multiplication. T equals these two answers. And let me know when you're ready. We'll go on to the next one. Perfect. All right. So here we have our dosage D for each patient. P can be calculated using the equation blank. So again, we need to find the unit rate of our graph. So if I choose this first point here, if I follow it all the way down, what is my x coordinate from the first point? No, you're fine. You're not at all, I promise. So if I'm looking at this first point, right, what would be my coordinate pair? So going all the way down and then going all the way to the left, what would be my two numbers? 2.4 and 100, perfect. So remember, our bottom number comes first, so 100 comma 2.4. So now I have to write this as y over x. That 2.4, 100. My goal is to get a 1, so I need to divide by 100 on top, on bottom. And if I over here, it tells me I get 0.024. So this right here is my unit rate. So when I look at for blank 1, I'm looking for an equation that has this decimal, which is right here. So for blank 1, I should have D equals 0.024W. Perfect, exactly. Where D is the dosage and W is weight. Okay. Blank 2 is asking what would be the appropriate dose for a 115-pound participant. So if our participant weighs 115 pounds, is that D or is that W? Is that the weight or is that the dosage if the participant weighs 115 pounds? Variable would that be for? The W, perfect, which is the weight. So I'm going to have D equals 0.024 times 115. So all I'm doing is taking the weight and plugging it in for W. And then all we have to do is multiply them. Which tells us that our dosage should be 2.76 milligrams. So 2.76 milligrams. So there are those two answers for blank 1 and then blank 2. All right, the next one here. So this graph shows us the amount of weight for bags of candy and then how much you pay based off of how much your bag of candy weighs. Okay, so we're going to read through all of these different statements and figure out which ones are true and which ones are false. We want to select all the ones that are true. Now remember that you have to read it carefully because remember your x is your first number, and x on this graph is talking about what? Is it talking about pounds or is it talking about dollars? What is my x value representing? Weight, perfect. So this first one here says that the 0.5 comma 2.5 shows that 2.5 pounds of candy costs $5. Well, if my first point is at 5 is here. 5 is talking about weight, not dollars. So this first one is out because this is the wrong variable that's attached to each of the numbers. So this first one can't be right. Let's look at the second one. It says that 0.4 comma 2 shows that $4 can purchase 2 pounds of candy. So if I look down here, I have my 4, but remember 4 is talking about weight, right? So should this be $4 or should it be 4 pounds? It's 4 pounds, right? So it looks like, again, the variables are mixed up, so it can't be that one. The next one says that for 3 comma 1.5 shows that 3 pounds of candy cost $1.50. So here I have my 3 pounds of candy and 1.5 for dollars. So does this third one here, is that one true? Yes, perfect. So this third one here is true. This one says that 2 comma 1 shows that 2 pounds of candy costs $1. So if I look at 2 pounds, does it cost $1? Is this one true as well? Yes, perfect. So far we have these two. The next one says the point 1.5, 0.75 shows that the cost is 150 for 0.75 pounds of candy. This one again is like that first one. Our first number represents pounds, not dollars. So this one is not correct. And then the very last one, the 0.00. If I don't buy any candy, I don't pay any money. So that one is yes, perfect. So for this one, we'd have these two, and then this very bottom one, the 001. So we should have 3. Perfect. Number 10. All right. So on number 10, if the total cost of renting a bike is $16, and if it's $16, I want to know how long did I rent my bike. So here I have my $16, right? Because my money is over here. If I take this line and I follow it till I reach my graph, and I go straight down, 4 exactly. So for this one, we should have 4 hours. That one was simple, right? Only more of them were like that. That's it. Here's our next one. Which point represents the unit rate for this situation? So remember, for unit rates, we want a 1 where my x is. So I have 0, blank, 2. So again, I'm counting by 1. So 0, 1, 2, 3, 4. So you're super close. Don't forget to look at it carefully. If I go up here, this first one is represented by 1/8. Do you see that? So it's okay, because I would see the 8 too and immediately go, oh, it's 8. But make sure you look at it carefully. So this first point is 1/8, which as a decimal is 0.125. If you don't know what 1/8 is as a decimal, remember that you can type it into a calculator and it will tell you. This one should be 0.125. It's okay, I forget too sometimes. It's hard to remember all the fractions and decimals. Is on next one. Which statement best describes the cost of pistachios? So we're going to use this point that they have highlighted for us, the 1.5 comma 1, and we want to know which one of these sentences is correct. If I look at my 1.5, that is my x, correct? 1.5, is that talking about ounces or is that talking about dollars if it's on the bottom of my graph? Talking about weights, perfect. So when I'm reading all of these situations, I want my 1.5 to have the word ounces next to it. So which one of these is the only one that could work for this situation? The fourth one, the bottom one, this one, perfect. All the easy questions are at the end for you on this one. Got all the hard ones out of the way. Perfect. The third one. So this one here is a little bit different, but we're going to do this the same exact way as we've been doing it before. So this is still my x-axis, right? Because it's still going from left to right. And my y is still this one because it's still going up and down. So I still want to have a 1 in my x. So wherever x is 1, which is right here, instead of going up to find where it touches my line, I'm just going to go down because my line is going down. So if I go down to where 1 touches my line, my graph, and I go all the way to my y-axis, what number do I end up at? Negative 0.4. Perfect. So the unit rate for this situation would be negative 0.4. And don't forget the negative sign when you're typing it in. Perfect. 2 more. All right, here's our next one. So Jamie's part-time job. So this graph represents Jamie's part-time job. We want to know how much money Jamie will earn if he works for 5 hours. So after 5 hours, which is right here, right? If I follow this 5 up to my graph, he'd make $40 exactly. If I follow it all the way over, he'd make $40. Perfect. So on this one, just type in 40. You don't have to put the dollar sign. Perfect. And the last one. I guess this last one's kind of tricky. Okay. So for part A, we want to have, for part A, we want to find our equation. Okay, so this is, we first need to find our unit rate. So I want to use this point right here because my line goes through my graph right in the middle of this intersection here. So what would be this coordinate point that my cursor is on? 1/5, perfect. So 1/5 is my y. What would be my x? What number comes first? 20, perfect. So I have 20 comma 1.5. And again, we're going to write y over x. And I'm going to have 1/5 over 20. Let me double check something really quick. Perfect. Okay, so it does work. So again, I want to have a 1 in the denominator, right? So I'm going to divide by 20 and divide by 20. Now, when you're typing this into Desmos, make sure after you do that 1/5 that you click in front of your fraction to get your cursor blinking in front of it. Then you can do divided by 20. And to make this into a fraction, I'm going to hit that button. So my unit rate here is going to be 1 over 100. So this is my y equals k times x. Did I move too fast there, or are you okay? Good. Okay. So for part A, we want to pick the answer choice that has this 1 over 100. The 1 over 100, because that is our unit rate. 1 over 100. Now, what this unit rate is telling us is this 1 over 100 means that for every this means that for every 1 kilowatt of power, I need 100 square feet of solar panels to get that 1 kilowatt of power. Part B is asking us, what size panel do I need to have 100 kilowatts of energy? Oh, which one is correct? Okay. So if I have 5 kilowatts, to go from 1 to 5, what would I multiply by? 1 times what number is going to get me 5? 5, perfect. So that means I need to multiply the bottom by 5 as well. So 5 times 500, sorry, 5 times 100 will get me what number? 500, perfect. So if I have 500 square foot panels, I will produce 5 kilowatts. So for part B, we want to pick this one. And then for part A, we want to pick that one with the 1 over 100. And then that is it. You should be good to submit it.